start with the background of today's session. I am actually till now, I think this is the around, in fact, perhaps 10th lecture session on mini hydropower projects, including one introductory. And we were in the previous, we covered different aspects of a technical feasibility study, starting with site selection, hydrological analysis, data analysis, then design of different components of the civil hydraulic structures, electromechanical structures. Then we did some social and environmental impacts and how to manage the environmental and social impacts, how to mitigate them, what are the safeguards that are required. Then I also briefly touched on how do you estimate the costs and benefits of a mini hydropower projects, which would be needed for the financial and economic analysis. So today I want to start with the overall scope, so to say, of a technical feasibility study. This will be some sort of a review of different components of my previous lectures, but also it will help to sort of summarize or integrate the different feasibility components. So I actually divided my today's lecture in 3 parts. One was, what is the basic scope of the feasibility study for a mini hydropower? Drawing sort of thing required at the feasibility study level, constitute a feasibility level study report. So I basically will try to walk you through some examples so that it will help in preparing a feasibility level technical feasibility study. Okay, so what basically is what should be in the scope of a feasibility study of a mini hydro? I think in the project cycle, Mr. Bart already covered the different levels of study and what are the steps involved in a project preparation, including the feasibility study, technical, financial, and other parts. But I would just like to now sort of specifically talk from a mini hydropower project feasibility study preparation, what would be the scope. Obviously, the main component is the technical viability. So we have to establish the technical viability of a project when you are doing a feasibility. Is it feasible technically to develop this project? And one important aspect of the technical viability is we have to do a comparison of the alternate sites or layouts, alternate ways of meeting or generating that power and energy. Also, one has to make sure that this is the preferred option technology, because since we are dealing with different technologies, is a mini or a micro hydro project, is that the suitable technology to be selected to meet the demand? are there any alternative technology that could also be used, which can be developed in a cheaper way, a cost-effective way, and in an environmentally, socially acceptable way. So technical viability has to show that the proposed project or a site is technically viable, and this is the preferred alternative. I'm using the word preferred here because, I mean, you could say it is the best alternative, but sometimes there are some trade-off. I mean, you can probably, because of the resource available, there are already other uh, factors that can influence a technology selection. It could be a national policy that's sort of uh, prioritizes a particular technology for certain uh, reasons that are part of the policy. Then the feasibility study, of course, has to also look at the power demand and end use possibilities. Okay, you have a mini hydro project of a, let's say, 800, 900 kilowatt or 1 megawatt size. Now, what is the power demand in the, I mean, is it going to be connected to the national grid? I mean, you could have a grid connected mini hydro projects also. It could be a isolated system or a small mini grid. So we have to first assess the demand and what are the end use possibilities. Because the reason I stress here on end use possibilities is also because we are basically assuming that mini hydro projects will be uh, the option to electrify a region where the power or electricity supply is not there, or it is from other uh, expensive or unreliable sources. So this has to be also, we have to establish the power demand and the end use possibilities. Of course, it has to be financially viable and economically viable. And this one has already been covered in other lectures. So we have to now look at what are the project costs. So the costs has to be different components of the project components and the total costs, and what are the financial instruments, what type of financial plan that has to be also established. And of course, institutional aspects, who is going to develop it, who is going to manage it, and other aspects has to be operated, has to be also uh, uh, sort of decided. And this will be based on the policy. What are the policies, the national policy adopted, or the policy that are in place. And also, when you talk about hydropower, we should not forget that hydropower is part of the water system. So there could be other uses of the water that we are using for hydropower. So we have to also look at the possibilities of multiple uses of water and how the multi-purpose uses of water are managed. So, and this, I mean, all of these aspects, I think in the previous lectures, I have covered to a certain extent, but today I'm trying to sort of cover it in totality as a whole. And so what should be the format for a mini hydropower feasibility study? I'm talking about technical feasibility study format. So I want to give you an example. And the example I will be walking you through is based in Nepal. And Uh, Basically, I will show you the reference that I have provided at the end of this of the lecture notes. Also is reference is given, but basically the content, the format for this is very specifically to a mini hydro or a micro hydropower project, because when you have a larger size hydropower projects, the content also slightly varies, because in that case, for larger projects, you will have to have very specialized studies. Uh, like for example, for larger hydro projects, you may need a special study on the geology. You may need a special study on environment. You may need a special study on other aspects also. So it's a very but for mini hydro projects, basically you have to include these specific parts. Like for example, the feasibility study report, for a detailed feasibility study report for a mini hydro projects, basically includes this 22 or so items. The first one is basically you start with the general information of the project site, where it is located, what is the name of the project, who prepared it, who are the counterparts in preparing this, who are the community members that were consulted are, and how was this project conceptualized. So this information is provided in the general information. Then we have to also, as I mentioned, do an alternative analysis. So why mini hydro? Why you are trying to do a micro or a mini hydro in this to meet the demand of the system or the local community? So are there any other sources? Can it be produced using solar, biomass, bioenergy, wind? So this has to be also evaluated, and why hydro, mini hydro, or micro hydro is the best technology selection has to be established. Then you provide the site information, as I mentioned, where it is located. The details I will just in the following slides I will show, but you have to provide the site information. Then you provide the technical specification of the different components. Where is the intake located? What is the size, dimension of the intake, the weir, the headrest canal, the gravel trap, the forebay, the penstock, the powerhouse, all these things, and the transmission distribution network has to be described in the technical specifications. Then you have to have a section on hydrology. What is the water availability, how it varies, and other aspects has to be described, assessed. Then you have to look at the multi-purpose uses of water. And is this water used by other uses, like for irrigation, water supply, and how this is managed should be also described. Then you look at what is the installed capacity, what is the optimum capacity, what is the layout. So you provide the drawings of the layouts, and where are the key structures sited? Is it in a private land or a public land or other types of land? What is who are the consumers? This has to be decided. And what is the total system load has to be described. Okay, and if it is an isolated system, I'm assuming that this is either a mini grid or a isolated system. So where is the nearest grid connection? What are the other mini hydro projects in the area? That has to be also thing. And what is the estimated income when you generate this electricity based on the tariff structure. And on coming Wednesday, on 10th February, there will be a special session on mini grid and tariffs. So, and as you know, any project sits on a given policy or a regime, regulatory framework. We have to, if we design or prepare a mini hydro project, we have to do it as per the policy that is in place in a particular country or area. So the estimated electrical income is basically estimated. Then is there any other end users like agro processing market? Because so these other end users has to be also described, assessed. Then the total income is basically the total benefits from this project is computed, calculated. Then what are the enabling environment? As I mentioned, what are the policy, institutional, legal framework that supports this project? What is the type of management are you talking about? Who will build it? Who will operate it? Are other management issues that has to be described? Then you have to have the socioeconomic details, like who are the beneficiaries, what type of consumers are there. And in fact, if it's a small micro mini hydro, you can even list down the different consumer types and the consumer even at the household level. And what are the rates? When I talk about rates applicable, I'm talking about the unit rates for the construction material, for the labor, for transportation, and other unit rates. Cost per unit at the project area has to be decided. Then we have to also look at the financial model. What will be the equity contribution by the developer? What are the loan requirements? And based on the policy, is there any subsidy that these developers get based on certain policy of the country or the region? Then we have to look at the environmental and social aspects of the project. What are the social and environmental impacts, and what measures are to be taken to mitigate these impacts? Then we categorize the project. As I think in the previous lecture, there are 4 categories of projects from an environmental social perspective in Mozambique: A+, A, B, and C. So we have to categorize this project because these, based on the category, the safeguard requirements will be different. So this is in general the content of a feasibility level study for a mini hydropower project. I will walk you through the different, I will show you, this is an example of a case of a detailed feasibility or micro hydro project. This is an example from Nepal, but I thought that this was, this could be also adapted in the case of other countries like Mozambique. And of course, then we'll need, the format would need to be a little bit modified depending on the local circumstances, the context. But in general, whatever I showed earlier, the different 22 parts of the study format are are given in this format. And I will quickly walk you through this format. As I mentioned, the first one is the general information about the project. Some of the terminology may be different in Mozambique. So for example, we call our local areas, divide them into municipalities and local municipalities, villages here. You may be using a different terminology in your case. So this first information, general information, gives you the location of the site and who were the members of the team that prepared this feasibility study. Is there a user committee already in place? Who were the persons that were interviewed, and other information is provided in the general information. Then comes, as I mentioned, is what is the hydropower potential over here? What is the monthly flow? What is the flow that exceeds 11 months in a year? What is the average flow? So this type of information is collected so that you get an idea of the potential from hydropower. And then you have to compare with other technology, like is there a wind potential there? Is there a solar potential? Is there a biomass potential over there? And why you are choosing the technology, why you are choosing a mini hydro or a micro hydro project has to be sort of explained here. And the smaller text here gives you some more information on this on preparing the feasibility study sort of report, format report. Then you provide the site information. Like in the case of Nepal, we are still, some of these sites are away from roadheads. So there are some, because we are a mountainous country. So in Mozambique, although you also have hilly areas, maybe the accessibility of the site may be different. So, and this will also, depending on the location, the accessibility from the nearest town or nearest center, the subsidy rates varies in the case of Nepal. So the fifth item is the technical specification, as I mentioned, and over here you provide the description of different components of the mini hydro project, starting with the headdress, the gravel trap, the settling basin, and you basically give the location of it, you give the length of it, and what are the dimension size of these components. Similarly, you have forebay, you have penstock, the length of the penstock, you have the power outside, the transmission distribution length, and other description of the other components. The next item is the hydrologic. So you have to give the description of the hydrological assessment, the flow availability, and other aspects. Then the seventh one is the multipurpose uses. Can multipurpose uses of water resources be provided in the project? So yes or no. If yes, besides the power generation, is it used for irrigation, drinking water? How would that affect the design of the mini hydro project? Has to be explained in this section. Then you look at the install capacity and layout. So you give a general sketch of the system, how it is, where it is located, what type of land use it is affected, and other things. So you have basically the layout of the intake and the conveyance system, where will the powerhouse be located? So you provide a sketch over here. Then you also then provide the communities, the villages that will be electrified. What is the name of these settlements? So this type of information is provided. Then what are the domestic loads? What are the what is the maximum domestic load that will has to be met by this project is described here. Then you go into the electricity market. What are the other end uses? As I mentioned, is there any small scale enterprise, small industry that can be supplied? Then you basically give the names, the locations, and what is the power and energy requirement is mentioned here. So are there any then are there sort of what are the other end uses of this that this hydropower project can support? What are the other, as I mentioned, I must have mentioned earlier, I have mentioned that a couple of times, that initially you meet the immediate household demand. But when there is excess of electricity power in a village or a community, after a few years, new business, new demand will develop. So what are the type of businesses that are likely to develop after 3 years are also listed, because demand is bound to increase after a few years, because when you have access to electricity power where you don't have reliable access earlier, demand will increase when you have this better access. So totally, you basically decide on the total system load based on this electricity market and the domestic uses. Then over here in Nepal, our utility like EDM, in Mozambique, we call it NEA. So where is the nearest EDM grid connection? Is it very near? What are the chances of grid connection to this location or the community? And what are the other mini or micro hydro projects in the area? The reason for this is you could also, when you have a number of micro hydro, mini hydro projects, you could learn from each other, or it could be combined. And maybe you could develop a mini grid of multiple projects so that the supply and the reliability can be improved, and it can also be cost effective. Similarly, we look at the estimated electricity income based on the tariff. We do it for household and other sector. We basically estimate the electrical income. What is the agro processing market? Because in the rural areas, there could be other types of markets. What will be the from these agro processing or agro mills, what could be the monthly income is also calculated. Benefit that will arise from the supply of electricity. And then we come to the enabling environment. When you talk about the enabling environment, the understanding of the local communities. Is there ownership? Is it demand driven? Okay, so this will help the success of this mini hydro project. And then we look at the management, proposed management of the mini hydro projects when it is developed. Who will be the owner? Will it be a private company, a cooperative, a community, or other agencies? So this has to be decided. Who are the key people that will play a role in the development of this mini or micro hydro project? Then you basically also prepare organization structure, who heads the committee, and what type of organization structure will be there. Then you also provide the socioeconomic details. For example, what are the agricultural products in the area? What is the social information of the beneficiaries? As I mentioned, what is the income level of the beneficiaries? What is the education level? These also will influence the success of the development of mini hydro projects, the education level. What are the other energy sources? No? Are they using firewood, kerosene? Are they using solar home system? Are they using liquid LPG gases? Are they using other sources of electricity? Energy is also important because the mini hydro may replace some of these other sources of energy. What are the facilities available in this area? I mean, post office, school, other uh, amenities availability are also has to be listed. Then basically, we also look at what are the other social, non-governmental organizations of women, because gender issues are also important. So these are also basically described in such a report. Then finally, we want to now also calculate the cost. We look at the benefit and the enabling environment. Now we have to calculate what is the rate of local materials like sand, stone, bricks, coarse aggregate, wood. What is the uh, how much do you have to pay for labor, unskilled labor, and other skilled labor per day? Because based on that, the cost of the hydropower project will vary. What are the transportation rates? If you need to bring building materials from a nearby location, what would be the cost of transportation is also important. Then we also, during the operation and maintenance, what will be the approximate, what will be the salary structure of the operators, the manager and the operator and other staff needed to operate this plant. So that will give you the annual operating financial model. Okay, where what will be the total contribution by the developer and how much will be a loan. Then based on that, you do a financial model, and then you provide this different uh, different outputs, model outputs, the financial uh, returns, rate of returns, what is the net present value, and other uh, uh, financial details. Then we look at the environmental and social aspects. So are the locate, what will the project have any adverse impact on any, like, is it located in a protected area, a forest land, or wetland? Or what type of land use that will be affected by the project is very important. What are the impacts on the biodiversity conservation and the natural environment? So will there be any impact on the downstream water quality? Will there be any impact on forests? I mean, do we have to cut trees? So these are issues that has to be evaluated or assessed. And then also, what are the impacts on the social? I mean, will it we have to be careful on the social impacts on the human rights, and will it impact any indigenous community people? Will it displace any population? So this has to be also assessed and listed. What are the capacity building? Does the local community have the capacity to support this project and even operate and take over the operation of these projects? What are the labor and working conditions? What are there any social? So are there enough skilled manpower in the area? Do we need people to be brought from outside? These are very important issues that has to be also listed. And also we have to look at the livelihood impacts of the impacts from the project. Will it affect in any adverse or way the livelihood of the communities? So what are the impacts on the health and safety and security? This also has to be done. What is the land acquisition, involuntary resettlement? Do we have to take land from private property from, do you have to displace any household, any family? That has to be also decided. Also, will it have any impact on the pollution, on the use of resources? These are also has to be listed. And finally, based on that, as I mentioned, we have to categorize the project based on the potential risk and the impact. And so this, as I mentioned, are the 22 different items that are sort of included in a basic feasibility study of a mini or a micro hydro power project. Okay, so before I go into the other second part, which is the what type of drawings are presented, I would just like to stop for any questions you may have. Carlos, can we take any question on what I just gave on the content of a feasibility study for a mini or a micro hydro project?
Yes, Divas.
Is this for?
You can ask for
is
questions.
this relevant?
I think you are putting a question, Diva.
Yes. So my question, actually, I was, I'll maybe in the next round, I'll put some, I'll come up with a poll, but what I wanted to ask was, in Mozambique, when you do a feasibility study of a isolated mini or micro hydro project, the content I describe now, does anybody have any comment on anything I missed or anything that is not relevant from your experience? Anyone? Like, for example, the question is, what is the current policy or national policy in Mozambique regarding a mini hydro project? What are the supporting mechanism from the government, from or the agency like FUNAI, for example? Carlos, was my question clear?
Yes, quite clear.
And who would be the FUNAI would perhaps be the agency who would be responsible to promote renewable energy, right?
We have 9 people attending this class from FUNAI, so I would expect someone to say something.
Yes.
Jaime,
Say
Jaime,
in Mozambique, and you could translate.
Jaime Nyakule, want to say something?
No, no. No, I don't want.
Okay.
because actually, although we'll be dealing with it, because our next step in this training program for mini hydro is also to deal with the project portfolio and the evaluation of the project portfolio. What I mean, how do you select a project for implementation? And for that one, we will need to know the national policy, for example. Okay, so what is the current to promote mini hydro or the other renewable solar bioenergy? What is the national thinking? What are the support that are in place? Sorry, maybe I was not, maybe I was speaking a lot, so maybe I was not. But if there is any question, I can repeat it also.
Morning. So I'm not quite sure if I'm correct. I think other colleagues can help me if I'm not. But I think that FUNAI is the responsible to promote renewable energy, and ARENE has a role in promoting private investments. So is kind of multi institutional responsibilities to promote renewable energy.
Okay, thank you.
Pedro Cachot, do you want to say something?
Discuss this at the end. Portfolio of project in the basket, mini hydro project, and other solar projects. Who is, so that portfolio preparation, is FUNAI responsible for that, or IRENA or other agency?
Good morning.
Yes, good morning, please.
Good morning. Roberto here for FUNAI. Good morning.
Good morning, Roberto.
Yeah, I think we have some problems on the internet. We have some cuts. Okay. But I would like to say that the responsible of the post of portfolio, yes, is FUNAI. Responsible of the portfolio of project, it's FUNAI, yes.
I would suggest that we make a break, some 10 minutes break. So we are back by 10:05.
Yeah, so basically, I will just continue with where I left earlier. Basically, as I mentioned, I presented to you the key components of a detailed feasibility study of a mini hydro project. And now let me just move on to the next part of my presentation on, because when you do a feasibility study, we do a technical sort of feasibility level design. So we have to get the description, the size of different components of a mini hydro project. And for that one, we need to prepare drawings, okay? Drawings showing the different components, the structures. And during my previous sessions, I have used the drawings of different components, but I want to now summarize all the drawings that are necessary to complete a feasibility study, level study. And I would list the following 4 points as why we need the purpose of preparing these drawings. The first one is the drawings are prepared as per the site conditions using surveyed topographical data and maps and the designed parameters. I missed D here, the design parameters and dimensions. So basically, mini hydropower projects, for that matter, is it is very site specific, because depending on the landscape, on the topography, we have to prepare, or we have to locate, site these structures. For example, just to give you a broad example, in the background picture I have of the dam in Mozambique, this arch dam is designed to suit the site there. Okay, if it was a different location or a different river, a different topography, the dimension, even the type of the dam will be different. So one key word is the site condition for hydropower projects. So we prepare a topographical map. Then based on that map, we locate these structures, and the drawings will show these structures, the dimensions. And these drawings are needed to estimate the quantity of the different items or materials of these structures. For example, how much of concrete we need, how much of earthwork we need, how much of steel we need, how much of wood we need, all the construction materials. We have to find the quantity, the cubic meter, the length, what is the length of the pipe we need, what is the dimension of the pipes, what is the steel structures we need. So this has to be shown in the drawing. Based on the drawing, we can calculate these items. Then once we calculate the quantities, then using the unit rates, okay, the cost of cement, sand, aggregate, we calculate the cost of different components, the civil structures. Similarly, for hydromechanical structures, calculating the steel, we calculate the cost. So drawing is very important, and the drawings are also used to assess the social and environmental impacts, okay? Because when you put your dam or a canal or a powerhouse in a map, the drawing in a map, we can calculate how much area is affected, the land that is affected. Then we can also calculate the population, how many houses will be affected. So based on that, we are able to do a social and environmental uh, uh, impact assessment of the hydropower project. And drawings are necessary to look at the location and the siting of the different structures and components. So, so we need the drawings of different components. Now, I would just like to sort of ask you, what types of topographical maps are available in Mozambique and at what scale? I tried to do some, unfortunately, I am not able to come to Mozambique now because of COVID situation. And so I have, unfortunately, if I were there, I would have visited some of your office and seen what type of maps are available. From the internet review that I have done, I saw only maps. And when I talk about these topographical maps, I'm talking about maps with contours and maybe even land use. The topographical maps also show what are and the major infrastructure, the roads, the contours, and forest area, agriculture area, settlement area. So, for example, do you have topographical map in a scale of 1 in 50,000 or 1 in 20,000? Because normally large scale 1 in million, okay, 1 in million scale maps are available, 1 in 500,000 maps are available. But for hydropower planning, you need high resolution maps. So can anybody tell me what type of topographical maps are available? Especially for initial
Yes.
planning.
Yes.
Yeah, yes, please. Yes, please.
Yes. Thank you. Yes. Can I ask
Yeah.
this question?
Yeah, please. Yeah. What type of, what is the scale
Yeah,
of?
we have some topographical maps available in an institution called the Senacarta. These maps describes all the situation in the land, describing streets, rivers, and all the infrastructures. So the scale, I think it's a little bit, it's big. Scale is 1 in 250,000. I think it's big. So we use the tools like GIS and Quantum G's to have scales for the project. The consultant normally use the GIS tools and the Quantum G's.
Thank you so much. Thank you so
Yes.
much. Thank you so much. I think this information is very useful. And as you mentioned, nowadays with GIS, you can do a lot of this work even without ground data. And as you mentioned, 1 in 250,000 is not very suitable for hydropower feasibility levels.
Yes.
So you're right. And
Yes, it's not.
yeah. So also, like, of course, for mini hydro, you may just visit the site and with using basic survey equipment, you can basically do the layout. But if you want to, for a little bit large, if you have medium-sized hydropower projects, then you will have to do site-specific topographical survey using theodolites and other equipment. And GIS can help, but sometimes even the resolution of uh, digital elevation models, for example, that are available are not good enough. And if you want to get an accurate quantity, you have to do a topographical survey. Like, for example, if you do a medium or a large scale hydropower projects, you will prepare maps in 1 in 1,000 scale, or maps, maybe a general layout in 1 in 5,000 or 10,000 scale. But the detailed map is in 1 in 500 or 1,000 scale maps also. But for that one, for large projects, hydro projects, you have a survey team that does that. But for mini micro hydro, as you mentioned, we can use GIS tools, and based on site visits, you can do the sketches, you can use measuring tapes and leveling levels that I also covered in the survey part. So thank you so much. Thank you so much. Yes. But sometimes I think in the future, because you have also aerial photographs, which can have high resolution. So I would think that if you want to design or prepare feasibility studies of larger, medium, or large size, small, medium, large, bigger than 1 megawatt, 5, 10 megawatt or larger, then you will have to have a special budget for topographical survey also. Thank you, but this was very important. Okay, so let me just move on. And basically, for a mini hydro project, these are the typical drawings. And I will just go over it quickly. First, you have the general layout, the headrest profile, because the headrest profile is, one thing is you have to make sure that the slope of the canal is accurate. You have to also make sure that the computation of the head, the water that falls from the forebay to the powerhouse, the elevation has to be accurate. Okay, so the headrest profile is important. Then you have map drawings for intake, different type of intake, side intake, drop intake. You have the headrest canal or pipe, forebay, penstock alignment, anchor and saddle blocks, powerhouse, machine foundation, transmission line, single. So these transmission single lines are connections to individual household, the transmission distribution for the mini grid. So these drawings are available. The reference I provide at the end has these drawings, but I will just go quickly over this layout. For mini hydro, you start with the general layout, then you just locate where the weir is, where the intake is, and how the canal or the pipe passes, where is the forebay and everything. Now, one thing in this layout, it's a simple layout. Normally, this layout should be on top of a topographical map. Then you know that what is the land surrounding this forebay. What type of land is this canal or a pipe is passing? Because we have to calculate the area impacted. Okay, so if you want to do a resettlement or land acquisition plan, then we need the reason I asked about the topographical map was that when you have a topographical map, you put this layout on top of the topographical map, then you can get the type of land that is affected. In most countries, they also have what they call cadastral map. Cadastral map are maps of individual property, owners of the property is also fixed. If it is not available, cadastral maps are not available, during the feasibility study level, you have to walk through this canal and the structures, then list out the owners of this land. If it is a public land, private land, especially you have to get the owners, you have to get the area that is affected, that information is required. And this is the headdress profile. So over here in the headdress profile, I think some of you who have engineering background will understand this very well. So it just shows you the elevation of this canal from like starts from 1410 meter and up to here. This is basically the up to the 4-bay canal. So then you have to make sure, because for hydraulic calculation, this slope is very important. And on the axis is the length. So you also can calculate the length of the canal, the length of the pipe, and based on the drawing like this. Similarly, you want to calculate the quantity of material in the weir. For example, you have a temporary weir here. So now you have to calculate the volume of stone masonry. So you have to get the dimension here, and you get the area and the length, then you calculate the volume from these drawings. Similarly, this is for the permanent. So these drawings are used also for two purposes. One, to just give you, if you want, when you are going to construct it, these drawings are used. Maybe there will be more detailed drawings in the construction period, but these drawings can help you calculate the cost and the quantity of the materials needed. So these drawings has to meet that purpose. Similarly, this is the drop intake drawing. Again, this is the gravel trap. So you have the dimension, the length, the width, and you want to calculate the quantity of different materials, that the reinforced concrete material, what is the volume, because for the cost as well as for sort of location of these projects. This is the headdress canal. So depending on the cross section, you calculate the quantity. So similarly, this is the 4-bay again, and then you have the penstock. Okay, this is the 4-bay, this is the powerhouse. Now, based on the topography, okay, based on the topography, you will get the length, the dimension, then you can calculate the quantity. And also, like for some hydraulic calculation, these drawings are important. Similarly, this is the anchor block. So to support, protect this penstock from damage, from vibration and operation, then you have to get the quantity of the materials used for the anchor and saddle blocks. Then you get the dimension of the powerhouse. Again, for this, to get the quantity as well as to get the size, no? Because you have the equipment. The equipment has to, the turbine generator size has to fit into this powerhouse. So this is drawing is needed. And you have the machine foundation, because when you have the turbines and the generators, they are heavy, and they are with the vibrations, with the flow of water, the foundation has to be strong enough. So this is important. Then to calculate the cost of transmission and distribution, you basically get where will be your different components of the transmission, so that, and how it will be, it will cover the area that it is supposed to supply electricity, will be provided here. Similarly, the single line drawing, in the sense, I mean, these are the electrical, where will be the turbine generators, where will be the control panels, and where will be other like earthing systems, the load controller, the ballast, and everything. These are electrical. And normally for mini hydro, sometimes these are standard. But large hydro, you need specialist electrical engineers, plant designers to design this. So drawing, as I mentioned earlier, is an important part of a feasibility study report, and this has to be prepared accurately as far as possible, because it will influence the cost of the project, the cost estimation of the project, number one, and also, as I mentioned, uh, to estimate the impact, what type of land is used, what type of, who are the people affected. So these are basically important parts when you are preparing of the drawing for a feasibility study. Okay. I think these drawings are relatively technical matter, and but I wanted to present it because these are important part of a feasibility study. But now I will move on to, at the end of the day, you need to prepare a feasibility study report. And this has to be, this feasibility study report will provide all the information on the technical viability, on the socioeconomic impact, on the cost and benefit, and the management structure, and the construction plan, everything. Now, this feasibility study report, as I showed for a mini hydro, is simple, that the format I showed. Maybe you can have a small report. But when the hydropower project is large, then you have to sort of have a more detailed feasibility study report. And I will just provide you some example, okay? Now, this is for a small hydropower project. Okay? This is a sample table of content of a feasibility study report. Now, if you see, this feasibility study is divided into different, we have a main report. I will come to the content of the main report, but you have appendices. Like I mentioned, the topographical survey mapping, the access road transmission line. Basically, because the hydropower project will be spread over a large area, okay? So you need to do, like I mentioned, 1 in 250,000 scale topographical map is a very, is a big, it's big. So it cannot really meet the requirement of a hydropower project feasibility study. So you do a project-specific topographical survey using theodolites and other survey equipment, okay, GPS equipment. And so based on that, you prepare the map. And this is prepared maybe in 1 in 1,000, 1 in 5,000, even 1 in 500 scale map. Okay, this is the first one. Then the second appendix is also hydrology, because the water availability is very important. So you have to prepare a good study on the hydrology and the hydraulics, because a lot of the design of hydropower project is based on hydraulics, because you have to make sure that the conveyance of water from the intake to the powerhouse is as efficient as possible, so that you lose as little head as possible, and also leakages, okay? It has to be, so this hydraulic calculation is very important. It also has to be, the hydraulic calculation also gives you the size of the structures. So there is a special appendix detailing all the hydraulic calculation. Then also, depending on the site condition, a sediment study, because sediment can have very negative impact on the turbines. So, I mean, it would damage the turbines. So you need a sediment study, so that your sediment handling, your sediment descending basin is designed properly. Again, there is also, for, as I mentioned, for medium and large size hydropower projects, small size, geology and geotechnical study is also very important, because if it is in a fragile environment, if the rock condition is not good, there will be settlement, there could be landslide, there could be that would damage the structures. So the geology has to be well studied. The geotechnical aspects has to be well studied. Otherwise, you have problems. Similarly, the cost estimate, the energy estimate, financial study, construction schedule, everything is also an important part. So the cost estimate details are provided separately. The energy estimates are provided separately. The financial analysis is provided separately. The construction schedule is provided separately. And finally, you have another volume with the detailed feasibility drawings, like the one I mentioned. The one I showed you is for mini hydro projects, but for medium and large hydro, these drawings are even in more details. Okay, so this is just a sample main report. You start, this is a little bit for a larger than 1 megawatt and other thing. So projects. So it's slightly different from the one I showed you for a mini and a micro hydro, but basically you have the salient features, then you have the introduction, description of the project area, what were the field investigation and data collected, like I showed the topographical map survey, what was done. Then you have the hydrological investigations. You need to know the flood, water availability and other things. What is the access road required? What is the geotechnical and geological investigations carried out? Okay, these are the investigations. The hydrology study is here, sorry. The sediment study, geological, geotechnical studies are here, and which are also prepared. Then the project alternative. Any feasibility study has to look at alternatives. If you do not have an option assessment, it's not really a feasibility study. So the option alternative assessment is an important part, because you want to get the most cost-effective, technically viable project. And then you have the project design and description of different components. I have covered that quite a bit. Outputs and benefits, the mini micro, it may not be that critical, but for a larger project, construction planning is very important, because you want to make sure you have enough resources to complete that project. Then comes the cost estimate, then comes the disbursement schedule, in the sense what the total cost, how it will be dispersed. Then, because you do a financial planning, you have to have that. Then finally, you do a project evaluation, where you calculate the cash flow, the financial rate of returns, the internal rate of returns, and to check the financial viability. So these are, and of course you have the tables and figures that are given. These are the figures, tables, and other thing, which I will not go into this. So this is basically the reporting part of the feasibility study report. So is there any question at this point? Otherwise, I would like to enter into a slightly, a discussion, sort of maybe have discussion for the next 15 minutes or something, especially to plan the future sessions on mini hydro project. So regarding the report preparation, is there any question, or is there any suggestion, or any information regarding the situation in Mozambique? I tried to look at, find if I could see any feasibility study available in the web for Mozambique. I did not get any specific. And sometimes these feasibility study are also little confidential. Not everybody will share, because these are cost involved. And later on, during procurement activities, when you have bidding for these projects, sometimes the cost, details of the cost, the developer would not like to share. But anyways, but you have to get the feasibility studies are very important, that they are prepared properly so that the technical, financial, social, environmental viability is well established. Carlos, is there any, do you think there is any question anybody would like to, or add something that I have discussed till now? Because I would like to, if there's no specific question, I would like to move on the project evaluation part, at least for the coming session. Yes, Carlos.
Let us just give a minute to see if there is a question.
Sure. Thank you so much.
Oh, I don't think there is a question.
Okay, no problem. I think we have, I think the next session, the next few slides there will be some, I would like to have some discussion sort of in the next part. Carlos, you are recording it, right? Okay.
I'm recording.
Just for your information, basically I was reviewing what I have covered till now and what I am planning to cover in the next 3 sessions from next week onwards. And basically, because as part of the capacity building exercise TOR, there is one section on evaluation of the project portfolio. So I had initially listed 3 topics on technical review and due diligence of the project portfolio. And the next one was basically the investment financial due diligence, environmental social due diligence, and the implementation plan. As we discussed earlier, FUNAI has a portfolio of projects that they are planning. So we would need to evaluate them and what should be the criteria basis for that. So I wanted to basically cover some of that in the next 3 sessions and then come up with the final at least not the final per se. We may not be recommending individual projects to take up, but we would like to make sure that the criteria used, the procedure used is something that we all agree. So in order for me to continue to deliver these sessions, I will need some information, okay? And based on the review, I will be in touch through Carlos and Bart, to touch with some of you to get over the next week to get additional information to plan my sessions. But from my review, I saw there was one document, there is a master plan. Let me see if I can, just a moment. There is a master plan by EDM prepared in 2018. Sorry, I was trying to get this document. I cannot. Sorry, let me just. Hello. And there is another document. Sorry. Yeah, this is the document, the Integrated Master Plan for Mozambique Power System. This is one document I saw, and there are certain, of course, I will not go into the detail. And there was another moment. Sorry. Okay. And there is the EDM strategy also. Sorry.
Divas, we cannot see your slides you're referring to.
Okay, just a moment. I'm trying to get back to the
You
slide.
have displayed the thank you only, the last slide. Maybe you can take one step back. Oh, yeah.
Yeah, okay, okay. Now I think I can, right, okay. Yeah, now you can see, right?
Yes, we can see it now.
So there was basically the master plan from the Ministry of Mineral Resources and Energy, and there was another EDM strategy of 2018 and 20. Now I would like to request our friends, what are the other relevant plans I think we should consider to collect information on the MHP, medium hydropower portfolio. Because from what I understand, there are number of projects identified by FUNAI and maybe by EDM and IRENA. So is there any public report that is available that we could review so that we can collect more information and include in our sessions, coming sessions?
Hello?
Yes, please.
Yes, maybe renewable energy strategy developed by FNAI.
Okay. Okay, renewable energy strategy. Yeah. Is this in Portuguese, or is it available in English also?
Colleagues from FNAI, can you help me, please?
Or Carlos, are you aware of this? Do you think there is English version? I mean, Mozambique version is okay. I mean, we could. I mean, I could discuss with some of you to summarize a few or make a small presentation for the benefit of all. But if there is an English summary version or something, Carlos, can you check?
I know the Portuguese version, but I can check if there is an English version of
Okay,
that.
okay. And maybe I'll discuss with you and some colleagues from FUNAI later, separately, early next week, and to see in the Portuguese. If you can send me the Portuguese version also, maybe I can just have a glimpse with it, and maybe I can get some idea on I may not understand all, but from the tables, I might be able to get something and we could discuss. Yeah, thank you. That'll be very nice. Thank you so much. And also, of course, yeah, I think that will be very nice because I'm trying to prepare for the the coming sessions. And of course, we will, I mean, this will be the coming sessions. I want to make it as interactive. I'll try to be as possible. And maybe, so we will have to look at what are the key criteria, what are the key technical criteria, organizational, financial, environmental, maybe geographical, regional, you want to have a balance or something. But of course, this will be depend on the national policy, because everything, no? I mean, there are technical issues, but it has to sit, it has to be managed under the national policy. So we will look at it, and we'll discuss that a little later. And also, the other thing I was thinking that if possible, can you see my slide on after 1 week? Is it possible for to have, let's say, 5 short presentation from colleagues from MIREM, ARENA, EDM, FUNAI, and CTA on, based on, like I mentioned, the master plan, the renewable energy strategy, some discussion on summary presentation on the project portfolio, what type of projects, maybe some, last time we were very nice, we are thankful from official from FUNAI who made a presentation on the Majau mini hydro, and also colleagues from FUNAI prepared a short salient feature of the 5 mini hydro projects, 5 or 6 mini hydro projects, which are either in operation or in the process of rehabilitation. But I would like the discussion for the presentation for next week is to cover a little bit more. Maybe there are new sites which are included in the portfolio. Would this be, is this request, would you be, willing to make a short presentation on your ideas, on the information you have on potential mini hydropower development in Mozambique? I listed the 5. If I missed anybody, any organization, please let me know. But I just, from my understanding, these are the key 5 organizations that are part of this capacity building exercise. Carlos, would this be, do you have any suggestion for this?
No, I think you are right. Probably they could prepare something and present it on the 12th. So the list is correct. So all the institutions are in here. The 5 institutions that are attending the course are represented in your list.
Yeah, thank you. I would very much appreciate if 1 or 2 or 3 from each institution would volunteer and prepare. It can just be a list, because I want to, of course, some information and some summary of the portfolio so that we can sort of find ways on deciding on the criteria to be used for evaluation and for criteria to be used for to selection or prioritizing and ranking. And I would like, I have some ideas based on my little experience from other places. I will suggest some criteria, but this has to be also a little bit it has to be relevant to Mozambique. So I will, of course, discuss this further with Carlos and Bart and our team member experts also. But I think if we could have maybe 10-15-minute presentation from each of these organizations based on their interest and their domain, that would be very nice. Because EDM, for example, would also look at more grid connected perhaps, although maybe you have mini grid section in EDM also. But I think from ARENA, it would be more on private sector, FUNAI more on overall renewable energy, and MIREM perhaps is more on a overall the energy sector per se. And I've discussed with Carlos, and then maybe we can come up separately, and we can come up with some suggested outline of these presentation also. Any suggestions, any comments from anybody on this, please? I was thinking that if this week you could prepare for, we have 1 week for next Friday, 12 February, that would be very nice. Let's say, I mean, longer if you want, but maybe 10, 15 minutes, few 4 or 5 slides on even references. If you could provide, we can discuss further. Any comments, suggestions? Is this, do you think this will be good? Carlos, any suggestions from your side?
Not at all. I think it's okay. It's clear what should be done.
Okay, thank you so much. Yeah. Basically, I think, I don't know if I had, this was, I wanted to discuss this at the, before we close today. And let me see, I think this was the, so these were some of the guidelines. The guidelines, the one that format I mentioned is from a guideline for Nepal. The reason I presented this is this guideline has been, prepared based on experience of the Alternate Energy Promotion Center in Nepal, I think over the last 20 years or so. And there has been a lot of support, especially from GIZ and other development partners, including the World Bank and the Asian Development Bank and other EU, the European Union, to this organization. And basically, these guidelines are, I think it is very relevant to countries like Mozambique also. And the second one is a guideline for study for hydropower projects. This is also for Nepal, since I come from that, from Nepal. So I find that a lot of input from international partners have gone there, and this also is based on the experience of the country and the department over the last maybe 20 or 30 years. So these guidelines provide the type of analysis, type of scope that a feasibility study, feasibility level study is needed for a hydropower project. And the third one is it's also a mini hydro design aids, which I have actually referred to many times. And apart from that, I had the references that there's the UNIDO small hydro program also has guidelines for small hydro, which the reference of I have provided earlier. So these are some of the references that will be that are useful for a feasibility level report preparation or study. Yeah, I think.
Thank you. I think you are opening for questions, right?
Yes, please.
Okay, Deepas, your opinion about the time that it takes to put the micro hydro in production, okay, in your Asian context, and then I will ask in your EDM support, technical support, how many projects have been online since the beginning and how long it takes. That's my question.
Yeah, thank you so much. Regarding my experience in Nepal and few other countries, I would say that for a micro hydro project, like or a mini hydro for less than 1 megawatt and or a few hundred kilowatt, it can be done, I think, like, because sometimes if you have a good team and good support, good guidelines, within 1 year, because you make a few site visits, or in fact, within 6 months to 1 year, you can prepare a bankable feasibility study for a micro mini hydro, okay? But if you are doing for larger, more than 1 megawatt, more than 5 or 10 megawatts, small size projects, as I mentioned, there are different components. So it can take as much as 2 years, 1 year, 1 to 3 years to prepare a feasibility level study, because you have to do a hydrological study, you have to do a topographical and survey, you have to do a geological mapping survey, you have to do a socioeconomic, social and environmental, and of course, the technical survey. So a mini micro hydro maybe can be done within 1 year, but as the size increases, it takes normally 1 or 2 years for slightly bigger projects. Regarding EDM, I do not have much idea. So I would request colleagues from EDM to respond to that.
Thank you. In EDM, I don't see much feedback. I think they should give us some feedback on that.
So, Mr. Kemal, maybe like in the next class, that is the reason I wanted the 5 agencies to make a short presentations. So then it would be helpful. I will discuss separately with through my team leader, Mr. Bart and Carlos, with the different agencies and the individuals to sort of support them, to help them. I will help them to prepare some of these presentations also. I work with them in the next 1 week. So maybe next class, we can go into the detail, more specific focus with Mozambique. So this is the reason I wanted this small presentation, but I will also work separately with them, communicate separately with them to get more information. Thank you.